So again, welcome back, ladies and gentlemen, for our last and final video on radical systems. Before we move on to this unit, there's a reason why we go through this review from grade 10, which are called radicals. These are obviously rational numbers that can't really be expressed by fractions or anything like that, like root 2 or root 3. One of the fundamental ways for a lot of you to look at what we're going to be doing is work with radicals and this radical formula. And in fact, a lot of you notice that the symbol for the radical is actually the square root sign. In fact, the very first one is square root. So there's actually a 2 here that's underneath that. And the a, b is called the radicand or under the radical sign. So we can't really split them up. But there is a property that we can use, the square root of a times the square root of b. And most students actually know what we're trying to do. When we want to change from entire radicals to mixed radicals or vice versa, we try to choose the largest perfect number for a. I'll explain it for this one. Example 1. Notice it says root 75. Basically, the whole thing is underneath, and what we want to do is change to a mixed radical where it has a whole number and a radical component. And in this example, root 75, the largest perfect number that can go into 75 is 25 times 3. Right? Yeah, what's so special 25? 25 is made up of 5 times 5. As a refresher, one more time, some of you might remember from a review way back in the first week. 1, 4, 9, 16, 25, 36, 49, 64, 21, 100, 121, 144, 169. These are all the perfect numbers. Notice some of you are slowly kind of connecting. Hey, wait a second, we kind of did this with perfect squares and difference of squares. Nice and done. So this is what we're trying to talk about. Now, I like going this slowly, root 25 times 3, notice under the radical sign, just like this, right? Just like this, AB. However, we break this up, like so. And what is the square root of 25? Although the square root of 25, when we evaluate, gives us the positive answer, notice it has a root 5, sorry, a 5 root 3. That's how you say this. So 5 root 3. And again, it's understood that it's square root. You guys remember doing this in grade 3 10? Did you guys do this? No, yes, maybe? That's okay. So you're supposed to actually be able to change, and that's what it means entire to mixed. A mixed radical means this. It has it's like a mixed fraction. It's like a mixed fraction. How about we go the reverse way? I know I really want to do example C, but example 2 is a little bit better. Notice it's 4 root 2, 4 root 2. So you kind of go the reverse. Instead of going from left to right, go from right to left. So I think a lot of you know what we're going to do for example 2a, 4 root 2. We square that 4. What's squaring a 4? 16. Nicely done. It is 16, right? So notice what I'm doing, ladies and gentlemen. I'm just going backwards. 4 is the same thing as square root of 16. Go this slowly. 16 times 2. I apologize if I was in your way. 16 times 2. Can anyone do that in your head? Athena? 32. Root 32, right? And that's the answer, right? So notice we now go from entire radical, mixed radical to entire radical. It's very, very different than mixed fractions, but same idea. Mixed fractions means added, whereas mixed radical means multiplication. And that's why this is a critical formula that some of you might need to remember. So let's do 2 harder ones. For question, example 1C, this is actually 1C. I know I did this in different order, I just wanted to show you. This is a fraction, and most students actually do not know how to do this because we really didn't teach it. However, what you can do is take the square root of 2 over the square root of 9. Now, believe it or not, we're not really there yet. But the reason why we actually can use this radical rule is because it's actually one of your exponent rules. Nonetheless, notice what we can do. What's the answer? You can't square root 2. That's not a perfect number. But root 9, hey, it is a perfect number. And that's the answer. Root 2 over 3. I know it doesn't look it. So if some of you want to say, Mr. Chan, that's another way of writing it. I think some of you are slowly understanding. Notice the 1, you can just pop it out. So these are all the same, but most students will just stop here. Let's pause there. That's okay. I just wanted to get example C out of the way. Question B, notice this one's a little trickier. So notice what you have to do. You have to actually take out that negative first, -1 times 6. Notice I can still do that. Can someone now help me out? Stan?
That's 336.
Nicely done. And you might need to use a calculator. Anyone have their calculator handy? 30. I actually don't know what it is. 36 on 5. Anyone have a calculator? Mackenzie?
180.
Is it 180? Nice. I didn't know. So -1 root 180. Notice we don't tend to put the 1. So negative root 180. That's the entire radical of this question. This one's a little tricky, so I wouldn't be surprised if you decided to do this one a little differently. Some of you might square that and you get 36, but then you have to remember there's a negative here. So just take the negatives separately, right? Before we continue, everyone okay? Before we get to our last question? Example 3, notice what it is? It's multiplication of mixed radicals, right? That's 9 root 2 times 4 root 7. So, although multiplication is commutative, and some of you realize, do I have to change some entire radicals? I would recommend you don't do that. Watch what we can do, and again, as an example, again, it's not the end of the world, but most students are going to do this. 9 times 4, that's 36. Root 2 times root 7, that's root 14. And notice, we just stop there. Sometimes though, when you multiply them out, like let's say we had root 2 times root 8, and we'll stop here. Still the same rule, you get root 16, everyone agree? But what is the square root of 16? 4. It is 4. And so you don't stop here. That's the answer we're looking for this example that I just made up. Okay, ladies and gentlemen? We'll obviously continue this later, but because of the time frame and the viewers at home, you're watching this, it's been a long day, right? So we'll take a look more about radicals when I see you guys again online.